Did you know that Excel can support location-based management system or LBMS in construction and project management? This is a key concept that focuses on managing work based on physical locations of activities rather than traditional critical path method or CPM. In this video, we'll create and share a dynamic template in Excel with 4 easy steps: automating buffer placement in linear projects, updating project plans and creating dynamic location-based charts, performing sensitivity analysis using Excel's data table function, and visualizing scenarios for varying project lengths and buffers. You can follow along by getting the Excel workbook via the provided link in the description below. Step 1 is automating buffer placement in linear projects. Our case study focuses on a transmission line project which is linear and location focused. The project runs for 250 kilometers and a minimum buffer of 2 weeks needs to be maintained between activities to provide a reasonable margin to absorb typical delays without significantly extending the project timeline. The initial project has 5 activities for which LBMS is suitable for optimizing workflows and minimizing the risk of delays. The first activity of surveying has a production rate of 39 kilometers per week. We can find its duration by selecting the total length of 250 kilometers and dividing it by the production rate of 39 kilometers per week, which is almost 6 weeks. Please note that numbers are rounded up and we can follow the same procedure to find durations of remaining activities. The durations in weeks are 13, 6, 8 and 9 weeks. Our first activity of surveying starts at week 0 and considering its duration finishes at week 6. For implementing LBMS, we use 2 rules of thumb, also known as Johnson's algorithm. The first rule is related to start dates of any pairs of activities. If successor production rate is smaller than predecessor production rate, the start date is equal to predecessor start date plus buffer weeks. Otherwise, the start date will be predecessor finish date plus buffer weeks minus activity duration. For example, consider second activity of clearing corridor for our transmission line. For the start date, enter if B4 is smaller than B3 to check if its production rate is slower than the predecessor or surveying activity. If the condition is true, the start date of our activity will be D3 plus H4. If the condition is false and the production rate is faster, the start date of our activity will be E3 plus H4 minus C4. In this case, the activity can be started in week 2. The second rule is related to finish dates of any pairs of activities. If successor production rate is faster or equal to predecessor production rate, the finish date is equal to predecessor finish date plus buffer weeks. Otherwise, the finish date will be activity start date plus duration. For example, consider second activity of clearing corridor for our transmission line. For finish date, enter if B4 is greater or equal to B3 to check if its production rate is equal to or faster than the predecessor or surveying activity. If the condition is true, the finish date of our activity will be E3 plus H4. If the condition is false and the production rate is slower, the finish date of our activity will be D4 plus C4. In this case, the activity is finished in week 15. We can automate the buffer placement using our first rule for start dates and second rule for finish dates, even if the project has hundreds of activities. Just select both columns and hover the mouse on the bottom right corner of the cell where the fill handle is visible. Double-click the plus sign to automatically calculate start and finish dates for all project activities following 2 rules of thumb. If you need a refresher on this method, the video links are provided in the description below. Step 2 is updating project plans and creating dynamic location-based charts. Our project client has informed us about an adjustment in the scope and a new activity of installing conductors has been added. We now need to update our linear scheduling method or LSM to account for new activity and other future additions or removal of activities from the project scope. The easiest solution to apply our 2 rules of thumb to any new activity is to turn our scheduling range into a table. And here is how. Select the range, including headers, and go to the Insert tab on the ribbon. Click on the Table button in the Tables group. In the Create Table dialog box, confirm the range and tick the box for my table has headers. This provides the same result as pressing the shortcut keys of Ctrl and T. Feel free to adjust the table and enter new activity of installing conductors with a production rate of 70 km per week. You can see that calculations for start and finish dates are automatically completed based on our 2 rules of location-based management system. We can animate our LBMS and create dynamic location-based charts which are automatically updated. First, select a cell on the spreadsheet and navigate to the Insert menu. From the Charts tab, click on a scatter chart with the straight lines. Next, right-click on the blank chart and choose Select Data. Then we should add a new series. For series name, the first activity of surveying is chosen. Series X values will be start and finish dates. Series Y values will be start and finish locations. Finally, press OK to create our first line of balance or LOB. We must now add another new series. For series name, the second activity of clearing project corridor is chosen. Series X values will be start and finish dates, and series Y values will be start and finish locations. Finally, press OK and continue the process for access road construction, foundation works, tower erection, and installing conductors. We can enhance the chart visualization for a better appearance on project reports. tools. Navigate to the Design tab in Chart Tools, and from the Chart Style menu, select a suitable style. The flow lines clearly show that there is no temporal or spatial clash between the activities, since the buffer has been automatically maintained based on the two rules of thumb. We can validate whether or not this is a dynamic chart. Let's start by changing the buffer to 1 week, and both calculations and chart are updated instantly. Changing the buffer to 5 weeks also shows the robustness of our method. We can also update production rates of all activities based on actual site data, and again our LBMS is updated dynamically. Step 3 is performing sensitivity analysis using Excel's data table function. Sensitivity analysis in location-based project planning is necessary to evaluate how variations in key project parameters affect the outcomes of location-specific decisions. It helps project managers to assess risks and uncertainties, optimize resource allocation, and complete cost-benefit analysis. In our project, we are interested in measuring the sensitivity of our project completion date, which is currently 25 weeks, to variations in two input parameters of project lengths and activity buffers. The first solution that comes to mind is using Scenario Manager in Excel. However, Scenario Manager is suitable for small-scale scenario comparisons. Data tables are more dynamic, scalable, and user-friendly for sensitivity analysis, especially when analyzing multivariable scenarios. Data table can analyze multiple variables over a range of values efficiently by using two variable tables. Also, data table automatically recalculates results when input values or formulas are changed in the worksheet. This is ideal for our automated LBMS to complete real-time sensitivity analysis. Let's start by considering different project lengths of 150, 250, and 350 kilometers. Next, we evaluate the impact of varying buffer levels on project completion outcomes. So far, we have only considered the base buffer of 2 weeks. By considering increments of plus 20%, plus 40%, and plus 60%, the buffer will be 2.4, 2.8, and 3.2 weeks. We should also consider decrements of minus 20%, minus 40%, and minus 60%. These capture both optimistic and pessimistic scenarios in our location-based management system. We have now set up our scenarios, and the project completion formula must sit in the blank cell. Click on that cell and set it equal to E8, which is the completion date for our last activity and also the whole project. Now we can select the range, navigate to Data tab, What If Analysis, and Data Table. The row input cell is related to the corresponding scenarios we have defined in the row, which are project lengths. The base project length is 250 kilometers, and our formula reads it from cell H3. The column input cell is related to the corresponding scenarios we have defined in the column, which are buffer weeks. The base buffer is 2 weeks, and our formula reads it from cell H4. Now we have automatically calculated project completion time for 21 scenarios, which are combinations of 3 project lengths and 7 buffer weeks. As you can see, the longest project duration is 37 weeks when combining 350 kilometers of length and 3.2 weeks of buffer. The shortest project duration of 13 weeks is achieved with a project length of 150 km and 0.8 buffer weeks. We can create a heat map in Excel to visualize the trends and patterns in our sensitivity analysis. This can be done by applying conditional formatting, and we should select the data range without headers. Then navigate to Home tab, and in the Styles group, click Conditional Formatting. Choose color scales and pick a predefined color gradient such as green, yellow, and red. You can pick specific colors for mean, mid, and max point to suit your project risk reports. In our case study, longer project durations are shown by shades of red, and shorter durations are visualized by shades of green. Step 4 is visualizing scenarios for varying project lengths and buffers. We can animate our 21 scenarios to evaluate sensitivity of project completion to 2 interdependent variables of project lengths and buffer weeks. For this, select the scenario column and hold the Ctrl key to select 21 project durations. Then navigate to Insert Chart and select Line Graph with markers. Then navigate to Select Data and edit Series 1's name to 150 kilometers. You can go ahead and change Series 2's name to 250 kilometers and Series 3's name to 350 kilometers. For a better visualization of the horizontal axis, double-click on the values. In the dialog box, navigate to Text Options and select Text Box. Now you can define a custom angle to prevent axis labels from overlapping. Feel free to adjust the chart style further to suit your project management reports. For example, you can change the chart style by selecting an appropriate option from the predefined templates. Several inferences can be drawn regarding the sensitivity of project durations to variations in buffer sizes and overall project lengths. We can see a consistent pattern where project durations increase linearly with rising buffer levels and extended project lengths. This suggests that both factors of buffer sizes and project lengths need careful calibration. This analysis highlights the critical role of selecting appropriate buffer levels and project lengths in location-based management system or LBMS. Overestimating buffers may lead to inefficiencies and prolonged schedules, while underestimating them can increase risk of task overlap and disruptions. Similarly, longer projects tend to amplify the cumulative impact of buffers and show that optimization is essential for maintaining cost effectiveness and timely delivery. By aligning buffer sizes with realistic project durations and specific workflow conditions, project managers can better balance flexibility and efficiency in LBMS implementations. This ensures smoother task sequencing, delay minimization, and enhancement of overall project performance. We know that Location-Based Management System or LBMS, Critical Path Method or CPM, and Takt Time Planning or TTP are three popular project management methodologies which aim to improve project efficiency and delivery. LBMS is ideal for especially repetitive projects, CPM is better for managing dependencies in unique or complex projects, and TTP is most effective in achieving lean and synchronized production flows. For successful project planning, it is recommended to use PMBOK principles and linear project software such as Tileless by Trimble or TurboChart to achieve greater precision and reliability. And there you have it, an easy and short implementation of location-based management system using only 4 simple steps in Microsoft Excel. If you found this video useful, please remember to like and consider subscribing. I look forward to reading your comments and seeing you in the next one.